Alrighty then. Hello. Welcome to the Monday live stream. I believe I am all rolling and all set and ready to do the thing. I'm going to just switch stuff around a little bit so that I can get ready to do my coding in a way where I can pay attention to what I'm doing. Oh, also, hey, this is you. And with that, I think we're ready to roll. So I have a particular task in mind today, and I'm not very well set up because I was kind of scampering around before the live stream, doing things like arranging to have my car fixed again. In this instance, it's because the car's tailpipe is like falling off, and you need to take it to a mechanic and have that be repaired. Seems doable. I have also just released the plugin. I've also just released the plugin Tube 2, and hopefully that's going to go over fairly well. It's certainly going over well enough for me because I substituted it for the previous one, Tube 1, which itself was substituted for the plugin clip only. And I feel as if this is going to get me a lot farther as far as getting the sounds that I want out of mixes and music that I make. I was actually even thinking about a lot of the stuff that I do is based around my synthesizer, like the modular that I'm doing everything with, and I've been evolving a rather strange song, but all of mine are like that. And my hope is I can use that stuff to put out an interesting sort of, I'm not sure what to call it, like progressive electronic drum and bass electro, I'm not even sure. I have specific things that I like, and I'm going to do my best to pursue those. But a lot of what I am working with is kind of fancy and the stuff that I normally appreciate. But I've also been working with the Surge synthesizer folks, and that has some very interesting aspects to it. Notably, I can run some of my plugins inside Surge as part of the synthesizer engine and modulate things and do whatever. And that means, I can tie stuff to envelopes and things or LFOs in the Surge engine. And that means more in terms of sound design, but it also means it's running inside the Surge engine, and that's not coded the way that I would code it as far as getting my sound out of a DAW. But it's pretty close. It's the equivalent of something like Logic, where everything that they do is in 32-bit float. So sounds that cover the full range will degrade given enough processing, but you don't necessarily have to do all the process. It's complicated. So what I've been thinking of is maybe taking some time, and it might be a good idea to, don't mind me closing a warning. There we go. It might be a good idea for my live streaming things. I could live stream a Logic session where I make up some music inside Logic using only only virtual instruments rather than my regular stuff, which I enjoy working with greatly. But that's not to say that's the only thing to do. Like, I get this sort of 70s vibe out of it. There's a lot of things that I like out of that. But there are entire genres that thrive on different kinds of approaches. Like, there are a lot of things that work well with, clean VST synths and things like that, and I can dirty them up and make them interesting inside Surge or indeed inside the DAW. And much of the stuff that I do, I know how I would go about making that in a like inside Surge. And of course, Surge is also an open source project, and I like the people a lot. In fact, that's where I got the idea to do Tube 2. Was they started talking about asymmetrical distortions and things, and had the technical backing to take it beyond what people normally say, which is, oh, I put the second harmonic on it. It's not as simple as that, but these are folks with the imagination to start asking interesting questions about that stuff. And when I dug into it a little bit, I found that I was getting interesting answers, and I'm happy with what I discovered. So maybe it would be smart to do some music making streams, but rather than being like in my studio as I know it, do a music making stream that's just sitting around in Logic with 1 million copies of Surge and seeing what kinds of music I might enjoy making it that way. We'll see. Anywho, I have said that I was going to do ultrasonic light, and that is exactly what I'm going to do. After all the Surge and also multiband distortion and also updating monitoring, which I have a monitoring 2 that is going to be coming out, and other stuff which I have not even begun to tell you about, I thought it might be nice to do a stream that's essentially very easy. And so that's what I have in mind today. And that also means I can keep an eye on live chat, and it's going to be way easier than me to engage in elaborate conversations rather than going all wordless. Because what you're seeing is kind of like on the days if I'm porting something to VST. And who knows, I might even have time to do that. But I'll be able to answer questions better and talk with folks better, because what I'm proposing to do today is not difficult. What I'm proposing to do today is actually very easy. And you'll see how many hours of work it takes to do something kind of dumb and simple and not difficult. Here's what I have in mind. We're going to make 2 variations on ultrasonic. Oh no, I already did the monitoring update. That required some attention on my part, but it's just as well, because that was the kind of thing that was going to require so much attention that I wasn't going to be able to talk very well during it. And that doesn't mean that it was challenging or difficult to do. What it means is that when I did the monitoring update, I was replacing not just another dither with the dark word length reducer, because I'd wanted to do that. And I also added 2 parameters into the selector. This is actually OS X Snow Leopard. I'm developing on my old laptop, and that's what I do for retro type stuff. It all starts here and then extends outwards. So with the monitoring thing, not only did I have to change the word length reducer, which was tucked in the sort of the end of the plugin. Yeah, I can actually show you. You're looking at Xcode right now, so let's see. Do I have that available? Nope, because I've been working on Tube 2 recently. So let's just open it. Mac AU. And it's fine if we just do a lot of talking today, because I'll be able to do ultrasonic on my own time, even if I don't get around to it on the stream. Here is monitoring, and here's what I changed. Like, I added a couple of things. For instance, you can see that instead of NJAD and NJCD, it is now DK, which means dark instead of not just another dither. And then PDAD and PDCD means a small pad, like 0.4 dB, which is what I was talking about that I was going to need to do. And then everything else is still the other options. And what I had to do was change very little here. And this, I don't think anything needed to get touched at all. But the switch statement, I added these two cases to cut. I'm not sure that's actually minus 2 dB. I think it might be actually minus 0.4 dB. Whatever, it worked. And then all of the other case statements had to be incremented. Otherwise, stuff would get screwed up. And there's all this stuff, and there is also places where the case statement is being, the thing that I incremented is being updated, including in the comment and in these places. And then there as well. And then that's actually changed a hair, which is, I'm not exactly sure. Why that would be, but it is. It could be processing -2 if it's like that. We'll see. I guess I used that. So that's something I didn't even think of. And that's why this required all of my attention and I wasn't able to stream it. And then this had to be updated. And that's not where the case statements are, right? I had to change these. And then those are right there, so I knew to change those. And then the first time around, I didn't spot these. And I had to change these as well, because otherwise all the gain levels on cans were completely screwed up. Hey Moloko, hey everybody. The Surge team is very interested in the new DAW Bespoke. And it's lovely to watch, because what I'm seeing there is the Bespoke guy is doing this strange sort of modular synthesizer-y like thing, and with animated noodles between parts, and is using similar technology like Juice to what Surge is doing, and has been updating his stuff in parallel with Surge adapting their stuff to better align with Bespoke, so that the projects are kind of converging and cooperating and rapidly changing around to make everything work together. And here's our last case statement. And then I also had to put in this. I have not played with Bespoke yet. I tend to be stuck on Logic because I've been using that for years, and it's one of those things where it's like if it's your typewriter, then the energy is on what you think of doing with it, but you don't necessarily change that out and try to use a new typewriter. And so this B is dark, and I went through various stuff getting this to work the way that I expected. And we also now have two different options here, because it should do the 16-bit, which is this, either if it's the regular pass-through or if it is the padded pass-through, which is 3. And all of these things are just dumb maintenance stuff, but as you can see, there's so much code here that and let's see, the other one was up here, and there it is. I had to get all of that stuff exactly right, but there wasn't much to say about it. We'll close that out. and begin to get ready doing our new versions of Ultrasonic. I would say what makes it so hard to emulate a hardware unit in a plugin is several things. And some of this is just my own perspective. Like, there are people who think I'm full of crap and they don't have to use my plugins, and I'm not cross with them at all. It's just that I'm not going to do what they tell me necessarily when they believe my theories around this stuff are nonsense. I don't think they are nonsense. So there are several things that degrade sound in digital audio workstations, and they typically have to do with the kinds of problems that only digital processing impart. There are two areas in which this happens, and one of them is word length, and one of them is the frequency domain. In the frequency domain, you see this with people freaking out and demanding that everything be oversampled like a million times, because high frequencies, if you do nonlinear stuff with them, like distort them, will tend to generate higher waveforms. And if you generate a higher waveform that's above the sampling rate, then what you get, or above the Nyquist frequency is technically, that's half the sampling rate. What you get is it bounces down into the audio range again. So you get a wrong note. You get an overtone, but the overtone doesn't belong in the harmonic structure. And that does a lot. That is used intentionally by old samplers and stuff, are very much set up to, there was no way they could do anything else at the time. And that's a lot of what makes the sound of that. It makes a sort of cruder, more opaque sound. There's a metallic quality about it where if you have a percussive noise, think of it like a tom-tom versus a snare drum. If you have the tom-tom, that can be tuned to make a nice doom and a nice clean sound. Whereas if you have a snare drum, there's something rattling on one of the skins of the drum. And so it makes a very different kind of sound. And that doesn't make it a bad sound, but it does really change the whole tone of everything an awful lot. And I think this is one of the reasons why samplers work very well, especially your older samplers, work very well for backing tracks and things like rap and hip-hop music, is the percussive stuff is generating all this aliasing. And that makes the sounds in the sampling sort of more generic. They wind up being kind of like cartoon versions of themselves, and less attention is drawn towards the fine details of like the rosin on the bow of the string or whatever. You're not really vibing off the liquid quality of the timpani head or any little tonal thing like that. Instead, it's the cartoon version of it. It's like newsprint version. And that changes the way stuff hits, and it changes the way that attention is drawn to things, especially when we're at lower sampling rates. The other thing is quantization in the word length domain. And that's sort of my deal. That's kind of what I focus on, because every single, like if you're working on a floating point bus, so you're doing this stuff and you're making a lot of processing happen on audio samples coming in, and you're having them come in at 32-bit floating point, which means as the volume goes down, the detail that you can get into the reverb tails and things are just astonishing. It's essentially, 32-bit floating point is sort of like 24-bit fixed all the way down. No matter how quiet you get, the value that you're keeping is going to be the same as 24-bit, or more like 25 really, no matter how quiet it goes. So the quieter you go in floating point, the better off you are, and the cleaner and purer the sound is. and you can calculate that stuff as much as you like. Trouble is, if you go beyond full volume, like you make something that's 1,000 dB louder than the regular music that you're doing, your 24-bit is now scaled to that. And so if you were working with stuff like that, but perceiving it somehow at your normal level, let's imagine you do that, you've got your audio, and then you straight up clip it. You go like, okay, it would be a very high value. It'd be hundreds of thousands, millions, where normally the range is going to be between 0 and 1. And you've got your value. This is on a sample-by-sample basis, so it doesn't really work the way that I'm talking about it. Point being, when the amplitude is turned up that high, the steps between the 24-bit sample are much higher than you'd think. And even if you go to just full scale, like turn it up to clipping, and your waveform goes right to 0. It doesn't clip, but it goes right to 0. Between 0 and 6 dB down, everything that you're recording and everything that you do in the calculation is effectively 25-bit floating point. 25-bit fixed point. That still quantizes. Now you can quantize to 24-bit on the output of your DAW by going to like a playback device of some kind. That, you're not really going to hear that all by itself. You might, if you have really great speakers, like one guy who can do this is Bob Olson, the mastering engineer and Motown guy. And maybe you can sense something is going on with it some of the time. You'll never be able to really like blind test it or anything. Truncating to 24-bit fixed point. But when you're working in the DAW and you're doing a bunch of calculating and the values that you're using are also 32-bit floating point, the same as everything else that you're using, then what you've got is a situation where every little calculation you make is going to quantize everything to 25-bit fixed point every step of the way. That adds up. So one of the reasons why people have problems getting your analog sounds out of digital audio workstations is they do not take that into account. Now I do. You can see in the ultrasonic code here, my biquad filters are being calculated in long double. That's like 80-bit or something like that. It's double is already 64-bit, and that's already pretty good, but I just did a little bit of overkill because that is the way that I choose to do this stuff. Oh, noise research. Are you the person who emailed me? Because I have made like a little mental note of that. I think, yeah, is this what you're talking about? This is the note that I made. You must be, because I can't imagine anybody else popping up. And you're doing exactly what I said people should ask you, what you should ask people about. Mind you, there'll be more people at the end of the stream, but as long as you can wait a couple of free weeks, because there's a queue of things coming out, let me describe what might be good. Circuit breaker, auto mute, it cuts in, but rather than going to silence, I thought what might be nice is this. We will switch to a super clip stage, which might be, like a tube 1 style, or it could be just hard clipping, at which you set the threshold of how loud the raw clipping is, and then there's a timed release to let it go back to unclipped again. And then you can change the timed release from maybe a couple of seconds for working, a couple of seconds in absolute minimal clip volume would be close as it would get to a auto mute that would go to complete silence. But if you made it a very, very short release time and you had the clip threshold be not as quiet, but it would be kind of quiet, so you get a sound, it starts to become an audio effect. And I don't know if anybody has done that, because it's kind of a nasty, grungy effect. It would be probably be good to have it be a either 80 clip style, like we'll use clip only for it, or just raw digital clipping. Honestly, I think 80 clip would be better. And doing that means that you'd have a interesting sort of gated clip turn on and offer that might do some interesting things. So that seems like that might be a good thing. I think we could do that. Oh, it looks like I have 5 stages in ultrasonic. Look at that. Alrighty, yeah, you're going to have to wait, but maybe I can code that one next week. Seems doable. And we'll make stuff happen. I mean, the key thing is, now I have it in one of my note cards, which the note card today was this, and this is the stuff that I'm going to be doing with ultrasonic. So let's see, first of all, we're going to be doing a couple of different variations on this, so let's first make some new projects. I have my coffee sitting in the way of the laptop. It's not like I'm going to be doing really hard, demanding thinking today, but it's also going to be a very busy day because I got a variety of stuff going on after I finish streaming. And I got to go through all that stuff, and then the rest of the week maybe I can look into stuff like the Surge/Logic Stream. Honestly, I've enjoyed working with the Surge people so much that I honestly would like the idea of doing a sort of Surge branded Airwindows Jam stream. And it may or may not be my notion of exactly what I would do with my music, because I really enjoy like analog instruments and guitars and things like that. But I love the idea of doing a music stream where everything that I'm doing is like open source software, except for Logic, because I'd be doing it inside Logic. But honestly, if I was doing it inside the new Bespoke thing, I could do something that was literally all of the things. I just don't know if Bespoke has a mixing section that allows you to run plugins, because if Bespoke has a mixing section that allows you to run plugins, I could run a version of console in it. Then that would be exciting. So let us go forward and do a ultrasonic. I believe we can do a mono. That's what you're seeing here. New project gives you the option with Cocoa View, and I've got that set up to give me a stereo version of the AU. Okay, I like it. You know, it's about, I really should look into Bespoke now, especially since I know that Surge is working with them, working with the guy. And I know that's becoming a thing. And I know that that is another, like, it feels like the final thing would be to do like jams and the making of music on a live stream where everything about it from beginning to end was being done out of open source software that people can just download and have. Because I've been doing that for years and I'm very committed to it. And Surge has been doing that for years, and they're very, oh, Lorenzo, you need to try Tube 2. It's going to blow your mind. And that is partly because I talked to people in the Surge community who had very striking ideas about how Surge 1 wasn't enough, but it was not just like, oh, you suck, it sounds bad. They were like, I don't know if anybody else has really managed to handle this particular concept, but I know that this happens in real tubes, and you need to... It also happens to me sometimes in the KVR forum. Sometimes on the KVR forum, people will jump all over you and be like, rah, 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 rah. And then you find out that they're big fans. They love what you're doing, and they really appreciate it. It's just that there is no off switch as far as they're not holding back. If they have a thought, they tell you. And that's very useful when you have, I guess, the maturity to be able to accept it for what it is. Because, like, if you're inexperienced or feeling insecure or whatever, that stuff is deadly. It can get you to stop working. But that's not what they want you to do. They don't want you to stop working. What they want you to do is like, wow, I see that you're doing this, and I feel that this should happen, and so therefore, can you please incorporate this, which I don't know how to do myself? And you could say, oh, come to my Monday streams, and I will show you how to do the coding. But that's also years of learning how to do that kind of stuff, and they're not necessarily ready to do it. But there's this point that they understand, and they want that incorporated. It's all interesting. So, let's do a couple of variations on ultrasonic. Firstly, there's an ultrasonic Lite, and then let's see if Logic or if Xcode crashes if I fill it with too many projects. And let's do a separate one. Ultrasonic Med for medium. I hear somebody revving a small engine outside. That's fine. I'm going to be revving small engines a lot because I'm going to be mowing my lawn and getting out the weed whacker and kind of polishing it up a little bit. It's getting around to that time. Every couple of weeks or so I need to do that. Honestly, I would love to be able to have my lawn be completely overgrown and in a state of nature. It is a backyard, so it's not that big of a deal. The trouble is that there was a time, some years back, when I was really struggling with the Kagi thing and keeping that on the rails, and Kagi being Kagi shareware and doing Airwindows as a commercial thing. And I did let the yard revert to a state of nature. Unfortunately, I had Virginia creeper back there, and by the time it was finished, it had torn down entire trees to where they were falling on neighboring houses and stuff, and I had major cleanup to do. So I've never let it go back to that. Yeah. Bo Noise Research actually asked me to do that by email, and I said, seems doable. I've got a lot of projects in mind. What you should do is come to the Monday stream and ask me. Which Noise Research then immediately did, and so I'm very positively impressed by that. I feel like this is the place, I said, and I don't actually know what gender Noise Research is, so I don't want to by default say he, but I actually said, you know, even if I can't code the thing immediately for you, it's possible that somebody else in the chat can. And that is also true. So, Bo, I think you're actually working entirely in Reaper. But that would be, and Reaper does already have auto mute. But, yeah. And I'm not sure how much you'd need auto mute for intersample peaks, because those are not as high as the kinds of peaks we talk about when you want to just instantly break the volume of the thing. One interesting side effect of the auto mute is if you had a sound that instantly cut in at an unbearable volume rather than sweeping up to an unbearable volume, rather than having a single tick as it goes out of bounds, you could have a situation where the auto mute would kick in so fast there would never be a sample spike at all. That could be interesting. But I don't know, we'll see. And now I have done both of my ultrasonic things, so what we're going to do is move these over here. Move my source over there under chat. Yeah, isn't Max another sort of node-oriented kind of thing? where you're scanning around. Scanning around is a strange way to put it. Isn't it one of those ones where you're dragging noodles between little nodes, kind of like Apple Shake back in the day, or Nuke the Compositor, or some things in... I'm not even thinking of the names of this stuff. I need to be thinking about this. And yeah, I have coffee today, so... I also have my note cards handy, so if we wind up generating lots of ideas, I can write them all down. Here's the first thing we're going to do. As you can see, Ultrasonic has no parameters. There's no controls on it, and that's going to be the case for the other ones, but Ultrasonic does have variables. And we're going to copy these. So now we're going to work on the medium and light versions. Oh, one thing first though, ULTR. So the way that I increment these is I take the subtype and I increment it by 1. So we'll call Ultrasonic Light the second one, and then the medium will be the third one for no particular reason. It's a little arbitrary. As you can see, that is saying question mark, question mark, question mark, question mark. And we don't want that. So we will start with ULTR, but then we're going to step up ULRS. And I just increment those when I do this. So light gets to be S, and then medium also requires some attention. R, S, T. And now I have two different versions adding to what already exists in Ultrasonic. And we can move onwards to doing these H files. Yeah, the reason I decided not to call my thing Fuse is that I can imagine wanting to call another plugin Fusion or something like that, because fusing means melding stuff together, and so there could be a way of using it, whereas if I call it Circuit Breaker, it's a more awkward set of words and just sounds like what it would do. Calling something Circuit Breaker means, oh, it breaks the sound, does it? And if something happens, and that's literally what's happening. It's equivalent to a circuit breaker in electrical power, which does the same thing as a fuse, but you can put it back, and it would be putting itself back. And that's why that would be the name of the plugin, I think. Oh, Gen is an operator in MaxMSP. You can literally type in C-type code. You know, another thing that does that is Faust. There are Faust compilers on the web that you can load up a web page and have a MIDI device plugged into your computer so that web MIDI can receive its notes and things. And then you can program oscillators and things in Faust on the web and play them using your keyboard. It is really about the coolest thing I've seen. To the extent, like, it's the coolest thing I've seen given that it is software synths. So you're not going to get the kind of rawness that you would get if you were soldering together stuff out of CMOS gates and things, where stuff could be a little sketchy, or you can have an intermittent connection, and the rise times and stuff are finite, and the whole thing is not being constrained within a sampling rate. We are, in fact, still talking about software synths, and probably software synths where, because that's something I've learned, we're probably also talking about software synths where the designers like diligently made everything be afloat. All of the little variables in software synths are very frequently just 32-bit floats. And that's because you can compile, especially for Intel processors, although I think that the M1s are able to handle that just fine. But the Surge folks are doing all of their filters and things with special coding, allowing them to do individual filters for every note of like a 16-voice polyphony or however many voices Surge gets. And the way they do that is by getting down into the very details of how can we do as many things simultaneously as possible. Can we run this in parallel so that we can do 4 operations for the price of 1 by loading up the processor with this and that and thus and so. And they've successfully done all of that at the cost of all of their word lengths for all of their oscillators and filters internally to Surge is all based on 32-bit floats. So they don't get, like, the Airwindows plugin tone is not available to them because when they do more and more processing, it will end up degrading the top 6 dB of the signal. And when we're talking about like oscillators and things, a lot of those by default run from -1 to 1. So they're literally doing stuff that always uses the ranges that will gradually degrade when you're constantly returning to a float every single little operation you do. So it's a trade-off. It's a trade-off between being able to efficiently run lots of stuff without too much CPU slam and this repeatedly dropping stuff to effectively 25 bits fixed point for only the outside edges of the waveform. Something that nobody really understands about. That's ignored. Like, digital signal processing never mentions this, although it is a reality, because nobody has ever considered that to be important until I came around, apparently. I confused people so badly with the dither float plugin. They were like, do I have to put this between all of my plugins? And I'm like, oh, no. No, it's a proof of concept. But that's the trick. I have been talking more and more about how I would like to code some VST/AU instruments. And I don't know how hard that's going to be to do. But you can apparently build instruments both in the audio unit. The core audio had some sample code for a thing called SignSynth. And back when I saw it many, many years ago, I did not understand how it worked. These days, I could probably figure it out, and I could probably work out how to make something happen. And VST also has VST instruments. I don't know how those work either. But I would really like to do sort of the Airwindows style of a synth where rather than being like, I'm going to use Surge for all of my online synths and that will be fine. Instead, it would be more like, can I make a single purpose synth that does something interesting and has the tone I need out of it, rather than approximating it in a much more complicated existing software synth. And it's like, I think some of the stuff that goes on as far as hardware versus software synths, or analog versus DAW-based synths, you got stuff like, for instance, Serum. And if I don't miss my guess, by the very nature of it, that's going to be maxing out one aspect of things and not dealing with another aspect of things at all. That kind of synth is going to be something that is based on extreme oversampling and high quality sample rate reduction. Like, it's going to use elaborate processing to do your proper brick wall filtering and completely get rid of the aliasing. And that's how you get the sound of something like that. But when you do that, you usually are going to have to code it very, very efficiently. And since nobody understands that 32-bit floating point numbers are not ultimate resolution across the entire range, they are only ultimate resolution as you fade downwards into utter silence, and then it's always enough. But at that top half of the waveform, the bottom half of the waveform, or I could say quarter, because it's like the way that scaling the floating point goes, your top and bottom quarter are the lowest resolution, then it's twice and twice and twice and twice and twice, going finer and finer. So any like waveform motion around the middle near silence, you're going to have way more resolution than you ever need at a floating point. But everything in those outside quarters of the waveform, within the top 6 dB of the waveform, it's always going to be processing at about 25-bit fixed point. And the more calculation you do, the more that's going to erode on you. And I'm real interested in experimenting with that. Look, parameters. We don't need any of those things. This is Ultrasonic. Ultrasonic has got... This is also an interesting point that I'm going to be digging into as well. It might happen sooner than doing the circuit breaker. It might happen after. Where this is an enum. Enum means you start spelling out words, and those become variables with these values. You technically don't have to write this equals. It's sort of a shortcut saying like, yeah, that's what this means. But we're never actually referring to the number of this. It's just every time you say, you know, get param 7, like here, for instance. This code uses that number in the enum that we've just made, and it says set parameter 3. But we could also say, and that would work too. When we do an enum, we're specifying something. We're specifying an integer, and it functions as the same thing, but it's descriptive. And Paul in the Surge synthesizer community suggested that I might want to take my biquad filters, and rather than just having them be, and there are biquad filters in this, rather than just having them be this, see how it says 11 there? I could do an enum and then have every little bit of that be saying a descriptive word. So Ricky, let me attend to your question in a second. I'm going to make sure I know what I'm doing here, and I might go through and do the medium as well. And then I'll do Ricky's question. And I'm just now imagining what it would be if suddenly I had Ricky Tinez in my chat. That would be... You never can tell as far as people turning up. I am following the development of a Eurorack kick drum thing from a company called Rabbit Elephant. I'm very excited about them finishing up their production stuff and making these things, and I have every intention of buying one when they make it. And they've got this new little parameter that is called meow. And I think I know what's up with that. There's only 11 of you here, so I think I can talk pretty freely. as to what I think it is. They left it uncommented on in the recent trade show demonstration, and then they kind of were a little cagey about it, and then they were talked about how they were delaying upper harmonics of the their triggers of various things. They were spreading it out in such a way. They were a little cautious about what they were doing, but it sounds like something I talked about doing in a plugin as well, and I was going to call it, I don't remember what I was going to call it. Oh, MAUV, M-A-U-V, because V is Roman numeral for 5, and MAU5 is, of course, deadmau5. And the whole concept was because I thought I observed in some of his stuff that he had kick drums going where the lows hit a little bit before the actual highs did. It would spread. And that's what I've been doing in my jams with the synthesizer and stuff there. Everything that you've heard over the last couple of weeks for demo stuff, there are some timers built into that system where the kick drum is being delayed almost a 16th note, but not quite, so that the kick attack hits an instant before the actual click is supposed to go. It is not perfectly quantized. It's always a little bit ahead. And then I have a snare drum and also a chord, and that is swung a little bit behind the click because that's how you get a snare backbeat to be big sounding. Oh no, I don't care about mauve as a color. And so the stuff on my recent videos demonstrates this principle that I'm making a groove happen by having the kick hit a little bit early and the snare hit a little bit late. And you can do that with any combination of things. Like I could have an auxiliary kick for sort of the clicky punch of things and be triggering that an instant late. Well, the Rabbit Elephant portal kick thing has multiple triggers for exactly that reason. And when they say a meow setting, I think of Meowingtons. I think of deadmau5's cat, and suspect that that guy is a fan of those Eurorack developers, as am I. So you never can tell how things overlap and what goes on. I've been pleasantly surprised at times when I found people whose work I really enjoyed, and it turned out that they had been paying attention to me. If people like what you're doing, they'll never tell you. You just find out later, and you're very delighted later. But generally, if people enjoy what you're doing, they don't. If people dislike what you're doing, they'll tell you real quick. But when people are enjoying, often it's like they'll smile, and they'll feel good, and they'll go about their day. And that's fairly normal. But yeah, I think I figured out the secret of the meow setting in this new portal drum that's coming out, and I'm very excited at my earliest available opportunity to get that. In fact, this is the only case where I've ever done this to my knowledge. I essentially joined their Patreon, but they don't have a Patreon. They have some kind of funny private subscription thingy. And I decided, what with them doing a low pass gate that was really good, and I don't have one. And if I did, it's like the cost of a DFAM or a Mother 32, practically. But they did a low-pass gate that was truly fine. And now they've got this kick drum thing, which I genuinely need. Like, only way I've been able to get close to that is with repeated Blue Lantern Eurorack things, which are much, much less expensive. But I also keep having to modify them. Like I've worked on the Blue Lantern stuff and swapped out capacitors and things where possible. And with the most recent one, there is this sort of 909 kind of thing. And the only way that I could get it to do what I wanted was by swapping out some of the timing capacitors. Oh, Jas has also observed the fact that the Buchla is now in Eurorack format. I know what that means. Yep. Jas, the interesting thing about oversampling that has me, like, it occurred to me not long ago that what I'm doing with the undersampling for things like not even the undersampling. My most recent tape delay essentially does oversampling but without attempting to filter or anything like that. It is running its virtual tape at an extremely high speed, and it happens to be simple enough to do that I'm able to get away with it. Like the most recent tape delay, the actual processing and filtering is not being run in an oversampled way, but the underlying calculation of the virtual tape speed, at its maximum speed, or you slow it down or whatever, and the way that you can modulate the pitch, that's essentially working the same way as oversampling. And that means that I could have various ways of addressing that, or doing something that acts a lot like oversampling, but coming up with my own way of doing it. So, stuff like, well, what if you modulated some of the taps so that you had a blurring of any artifacts that were in there? I don't know. There are ideas. Like oversampling with vibrato, that would be interesting. Oversampling with randomization so that any aliasing that you got wouldn't be birdies, it would be noise. And the thing about oversampling the control signals versus the raw signal, that is something I'm going to be looking into also when I revisit biquads, because there's a sequence of things that need to happen, and one of them is going back into the biquad so that I can do a kind of biquad that interpolates the coefficients rather than just the I/O, the control signals. And that is effectively what the Z-plane filters from EMU were doing way back in the day. And I hadn't implemented that part yet, so there is a Z-plane 2 line that will come out. It will eventually come out once I have that sorted and I have biquads that I'm satisfied with how they work. It'll be a matter of going through and updating those. And that will fix zipper noise problems that some folks have on those plugins. Those who just turn them up and make them be really distorted will probably never notice, but yeah. Back into the breach with these. I think I just did ultrasonic medium H. Yep. So where do we go from here? Firstly, we don't set any parameters or have any of them in this. But one thing we are going to want to do is initialize. So this time around, we're going to copy that out and put it here. Then, likewise, we don't have any parameters for versions of Ultrasonic because it's just a drop-in thing to do the stuff that it does. There is also a good reason why I'm not having it be something where there's a switch and all this different stuff. These need to be as lightweight as they possibly can because they can show up all over a mix. I wonder if Laurent Desaurus's open source oversampling code is like Secret Rabbit code. It's the sync interpolation thing. I don't know that much about it, but there's ways and ways of doing this properly. And we've removed that, and removed that, so onwards. Now we just basically take the entire thing, and this is going to be exactly the same, so I can essentially take everything from here on down. And swap it out, and it'll be fine. There are going to be no changes to the template code, so it's going to literally be the same. We just run with this. And same, like, see the floating point dither, exponent plus 62, and so on. Same deal here. Boop. And now if I build these, and I don't even need this to be open anymore. Goodness, where even was that? Did I close its file somehow? No matter. These will probably complain the first time around, but, or maybe not. Oh no, they probably will. In this version, sometimes it needs to build stuff first. Like this. This one is not ready to go. I don't know why the other one was. So because it's compiling these things in order, so it's trying to compile this before it's compiled public utility or AU public, but it did get around to doing it after trying to do this stuff. If I do it again with no other changes, it's fine. So now we have two variations on ultrasonic, which are ready to go. So what are we going to do with them? What question did I don't always have to answer all the questions, but I will. Which question was it? How far back do I have to scroll to see it? Does a linear phase anti-aliasing filter cause any color or character onto the audible frequency range? Yes. Linear phase filters cause pre-ringing. Just because you don't have phase doesn't mean that you get away scot-free. Analog filters have phase issues. So when you do a bunch of processing and you believe that because you've scientifically worked it out and can have it be linear phase, that doesn't necessarily mean that you have the same as everything being perfect. Pre-rigging doesn't exist in nature. Simple question, simple answer. Let's start doing our thing. Nothing needs to change up here, but things need to change down here. Ultrasonic Lite is going to be one instance. So the rest of this stuff goes away. And that means these also have to go away. Just the one biquad there. And those need to go away. And interestingly, it's the biquad C that we're going to want to use the Remember how I was talking about how I needed to use enums? If I was using enums, what would happen is instead of saying biquad C1, it would be biquad C biquad resonance. And that would be the same as the number 1. And knowing that it's resonance, or it could be biquad Q, which is the same thing as for when you're talking about filters. I might use the long word for it though. At that point, knowing that you're telling it to be 0.707168, hey, guess what? That is literally Butterworth. Butterworth is not a kind of filter design. Butterworth is a kind of filter slope. But since we're only having one, we're going to want to get rid of all these others and tell that to be exactly Butterworth. And lastly, we were going to... There's another thing that I'm going to need to do, but give me a second. I'm not doing it right this instant. These go away because they have to do with biquad filters that we're no longer using. And this goes away. And hey, we're almost done. That should build. It did. So here's the thing. I was going to change it to a 24K cutoff. If I did that, and I ran this at 44.1K, it would not work. You have to have biquad A/0, which is the frequency calculation that we start with, 0.5 or less. If it's a little bit over 0.5, the algorithm blows up. So we could do this, but that could be an issue. So what we're going to want to do is an if statement. And get sample rate is going to return literally the sample rate that we want. So we want to do this cutoff at essentially between 48K and 88.2. So 48K we're going to want to override and no longer have the 24K thing. Sample rate supports it if it's double sample rate or more. Well, Ricky, what I'm doing is using straight biquad filters because they seem to sound good. You don't have to have any latency, and all filters will produce ringing if the Q is high enough. Let's see, I had an if statement to do. So, if get sample rate was 44.1K, then we're going to keep on accessing get sample rate. We don't have to do that too many times, so it's all fine. And we revert to the 20, although we could probably do I want to like up it a little bit? Thing is, the higher up I push it, it'll clean up the highs, but it also just doesn't let the biquad be doing anything at all. I don't know about that. Let's leave it at this very minimal thing, because people could be using this intentionally for all I know. But this is not the number that we necessarily want. So if it's less than double that sample rate, but hey, instead, rather than being exactly 88.2 or less, we can just go close to that. And now everything from a higher sample rate up is going to be, or rather everything from the higher sample rate down, being either 44.1 or 48K, is going to recalculate this. And having done that, and doing this calculation, and having this built in here, and having our floating point dither and denormalization, we are now done with Ultrasonic Lite. It is ready to go. Next, we'll scooch that over to the side and do likewise with Ultrasonic Medium. As you can see, that still has the same ones I had before, so we're going to take those away. Only 2 stages of biquad filtering because it's medium rather than the full-on or the ultralight version. No controls, that's all still good. And we're going to edit this so that this has both of the ones we're using are being compensated for. And I have an additional trick that might be fun that we can do for ultrasonic medium. I think. Yeah, I like the idea. I just had an idea. Let's make them both be Butterworth filters, but remove that. Keep this and I'll tell you why. Remove these. Now we have 2 stages. This stuff just runs, so we don't have to edit anything in here. No mag airband type lift. This is variations on the ultrasonic filter. So here's the stuff that we're going to change. And if we used literally what this was, this is what we had before. Now if we change this to be biquad B, we've got both of those taken into account. And that would be a 24K. And my thought was to stagger them a little bit so that the medium would be cutting off at 22K. But here's what might be a little amusing to do. The first one that we hit maybe can be a slightly higher frequency, and then the second one could be not exactly the same thing. So First one can be the same higher frequency as ultrasonic light, and then we'll step down a little bit and have the second one be 22K. And since you can technically have biquad A be 22050, if I'm not mistaken, for still functioning at 44.1K, we'll have that initial one cut off at, in fact, hang on. Let's go back here and let's have the initial one be closer to the cutoff if run at 44.1K, which is useless, and so you shouldn't do it. I don't even know what the EQ cookbook is. I found public domain biquad code and basically rewrote it until it was the style that I understood. So yeah, our ultrasonic light, we'll rebuild again, is cutting off at 24K, except for that it'll be 21K if we're not at double sample rate. And the double sample rate would support cutting off at, I believe, 44? Yeah, it would give you ability to filter up past 30K. So we're cutting off at 24, which is not unreasonable. And then if it's so low that you can't set it that high because the 44.1K would have it be breaking, we'll have that be 21K rather than 20K. Now we'll roll off a little bit slower. And then with ultrasonic medium, we have two different ones. It's cutting off at 24 and 22. It's kind of splitting the difference. And the biquads don't match perfectly. Instead, that's going to make a slightly staggered filter where it doesn't start off being Butterworth, but then it rapidly becomes Butterworth as both of them kick in. And then even in our non-oversampled version where you're not running at upwards of 88.2K and you have to set the settings lower, but technically you could run this, but we're checking to make sure that we're not at double sample rate, and if we are lower than double sample rate, we're going to filter sooner so that the filter doesn't break. This does also mean that if somebody was running at 48K rather than 44K, they'd still get a little bit of a ability to filter ultrasonics and a little bit of improvement over aliasing performance, just not very much. Like running at 48K and doing this wouldn't be nothing. It just wouldn't be as good as what you could otherwise have. And we're having both of these be straight up Butterworth cutoff because what we're doing to make it interesting is staggering the onset of the filters. And lastly, I think what we're going to do is listen to these and test that they work. And we're not going to really hear anything even if I run at high sample rates. But we can ensure that it makes a sound anyhow, and that nothing atrocious happened to make it go wrong. And then I'm going to probably call it a day because I've been drinking coffee and I need to go pee. Let's see. Firstly, option drag to components and straight up drag to desktop. I don't know whose card that is. Option drag to components and drag to desktop. There we are. This is the kind of thing like some of the porting stages that I do where I'm pretty confident that it's just straight up going to work. Like I don't anticipate a problem here. In saturation, you are not necessarily producing overtones that will hit Nyquist. The question is whether the frequencies that you're working with are already high enough that they would, which is a relevant point, although I'm not really contradicting you. In saturation, you can be producing overtones that will hit Nyquist. Like if you threw a biquad filter on stuff and just filtered the crap out of it, then you could put the distortion on and you wouldn't necessarily be producing those overtones unless you had a sharp-edged transfer function. People really into oversampling often think of it as a sort of black and white thing, like, well, if you're not oversampling, you're getting all of the aliasing everywhere, and it's more of a gray area. It's more of a fuzzy state in there. Also, the amplitude of the harmonics has a lot to do with it. Like your square wave has high harmonics that do actually fall off as they continue to get higher. A sawtooth wave has high harmonics, but there's a different kind of stacking of the harmonics, and they fall off kind of faster. Triangle wave has high harmonics, but they fall off even faster than that. In any of those cases, technically the harmonics go on infinitely, but you're rapidly going to run out of amplitude, and the aliasing that you get is rapidly going to run out of amplitude too. And these are all things that can be exploited on purpose. So hang on, let's see now. Firstly, test to make sure that everything still works. Alien Kittens is 44.1K. And if we were to, there we go, run Ultrasonic on it. That's louder than it needed to be. No problem there. So let's drag out Ultrasonic Medium. This should not sound any different in any of these. That would be softening it the most, I think. And it works. And lastly, Ultrasonic Lite. And it works. And the CPU for each one of them is going to be lesser and lesser because we're just doing less with it. And I should be able to switch this off, which will stop the plugin processing, but it'll keep things playing. Sounds pretty much the same to me. So now what we'll do is we'll launch Alien Kittens 192, which is upsampled rather crudely to be at 192K, but it doesn't really have content up there. As you can hear, it sounds about the same. And firstly, Ultrasonic. Doesn't really sound any different to me. Technically, this is blurring the phase of the ultra highs a tiny bit. And if we close this, we'll have it change abruptly from original Ultrasonic with the 5 bands of filtering to raw and unfiltered. If I hear anything there, it's very subtle, if that. I don't think there was much of a change. You could measure that there was a change, but I don't think there was much of a change. And secondly, Ultrasonic Medium. And then if we close this, it'll switch to the unfiltered very abruptly. Again, I don't hear a change, but you're not supposed to. This is supposed to be inaudible frequencies only. And lastly, Ultrasonic Lite, and we're going to test that to make sure that that works as well. And if we close this, yeah. Which one of the things about that is what I'm also trying to avoid with doing this processing is it's got to be filters, but I want the filters to be transparent. And since the actual calculations of them aren't producing, like the calculation of a biquad filter isn't itself going to be producing a bunch of unpleasant stuff like aliasing. But since it's doing these mathematical calculations, you could be eroding the word length by just doing the repeated processing. And that's what I'm trying to avoid. So part of what I was trying to listen for there was that having the filter engaged shouldn't be changing the tone of the frequencies it's letting through, but it also shouldn't be flattening out the sound and making it sound worse. Because you can have that. You could have a pile of incredibly elaborate filters that were doing, say, a brilliant brick wall filter at 30K or something like that, and you'd run your audio through it. It would sure enough not be changing any of the frequencies below 30K to very high level of accuracy, but it could also be making stuff sound really thin and plastic because so much processing was going on that you started eroding the sound, doing so much, over-processing, that tone of over-processing that you get. And a lot of that is down to the word lengths of the calculations. I've found that when you really throw in a lot of overkill, as far as doing the calculations and keeping them accurate, you can retain more of that raw sound out of it. So there we go. So we've successfully done the thing. I will do the VSTs on my own time. And we're going to turn in early today because I got to run out and do various things. I need to do some grocery shopping. I have to mow the lawn. I have to weed whack areas. Just a bunch of chores that I'm going to go and proceed to do. Before I do, final notes in the chat. I'll look into this Kotelnikov at some point. Ultrasonic isn't my solution to aliasing, but it is something like it. What happens is if you're running at a high sample rate, you can stick ultrasonic between plugins that are nonlinear, and it will somewhat control or more aggressively control aliasing in those plugins simply by suppressing anything that it had that could alias, or like the way that stuff works, right? Say you've got your sample rate and frequencies, and here's your frequency range going up to 20K. This is the threshold of human hearing, and you can't hear beyond that, theoretically. You kind of can pick up some of it, but we're not so worried about that at the moment, because aliasing is more unpleasant than lack of those frequencies. If you had the frequency wall right there, Nyquist frequency, and you distort the stuff in here so that your overtones, right, are decreasing as they go higher in frequency until your distortion generates more overtones, and one of them is supposed to come in here. Aliasing means that's going to go and be plunked into the audio range at some place where you don't want it. And if you have more of a range, and you did that, then this would be within the sample rate, the higher sample rate. You'd have more space. It could represent that frequency. Now, if you're generating an even higher frequency, say here's your new sample rate. We'll call this 96K and this 192. And you're generating a frequency that's out here. Like for whatever you're doing around here, you're clipping it so hard, or you're generating something that is so nonlinear that it has just generated a frequency out here beyond the 96K sample rate. Well, what's going to happen? It's going to alias, because aliasing acts like it's reflecting off of the sample rate. As it goes beyond, it's like it bounces and starts coming back. But if you were filtering, like say a nice smooth filter beyond this point, doesn't have to be a brick wall. And, you know, I mean it that it doesn't have to be a brick wall. People assume that it must be a brick wall. Then you're generating your little frequency, and then it's just been turned down. So it's been suppressed. You're kind of canceling it. You're not ultra canceling it, but you've just attenuated it somewhat. Then, as you're aliasing off of that 96K tone, what's going to happen is first, this frequency out here, it's going to be attenuated quite a lot. Like even if your filter slope was very gentle, so that it was clearly still there by the time you got to this point, you're still attenuating it from the full volume. And so you're generating this aliasing frequency, but hey, it's quieter than it was because you put a filter in before you hit that nonlinear process. And then you know what? It aliases, it bounces back. Since you've chosen 96K for the frequency that you're using for your sampling rate, it bounces back. And hey, if you put another one of these filters in there, you just turn down the aliased frequency that was generated from this process. So that's what ultrasonic is for. Ultrasonic is being there so that you can put it between plugins that aren't necessarily sophisticated as far as aliasing is concerned. And it'll start suppressing the aliasing without doing like crazy brick wall calculation type stuff. The super aggressive filters I don't think are helpful. They're doing too much processing. They are too aggressive. And you can do a distributed form of this. Like if you have this gentle filter going through all the stages of a mix, and that's what I'm doing with stuff like Console 7. The newer plugins that I've got do tend to do that. You just continue suppressing the stuff that is in the region that you don't want without having to obliterate it completely at any one point. Because if you could obliterate it completely at any one point and then do stuff that has irregularities or discontinuities in it, you could be generating new aliasing frequencies, at which point, you know, it'll build up. Like you have it ultra filtered here, and then you do something which generates a harmonic here, and then you do something which generates a harmonic off of that harmonic, and by the time you're done, you've generated an aliasing frequency again. Now, as far as how IIR and samples interact in a biquad filter, it's basically, I can't tell you all of the details, but let me draw a little chart. Supposing you have a couple of different ways that you can save previous samples. Like you have audio going through some places in a calculation, and this is the previous sample that you had going in, and this is another sample that you had going in. And then you do a calculation, we'll call it F, filter I. So your input is producing, it's going into this filter. And let's say we can go into the filter and we can also do a sidetrack where this is the last input sample that you had, and then this is another input sample. These haven't gone through the filter yet. So we now have these to do for calculating. Then once you're done with the calculation, your filter has now produced its new effect. It's a high pass, or it's a band pass, or it's a low pass, or something like that. And this is the new sample that you get coming out. You can also save that up. So this is the last output that you had, and then that's the next last output that you had. What a biquad filter does is it's an algorithm that combines all of these things together in various ways. So it's able to do stuff like if you had just the filter coming in and you combined it with the last one that you had, this little thing is how much of just straight averaging you're using. And this is how much of averaging with 2 samples you're using, because these are just input samples coming in. You balance those out. There's formulas that you use in order to figure out how much of each of these you need. This is the output. So if you took these 2 things, you would have an averaging of the last 2 output samples being fed back into the calculation, or an averaging of the last 3 output samples being fed back into the calculation. And when you combine all of these different places with addition and multiplication, like I'll write the X, I'm trying to make pluses that look like pluses, but I draw them too small. So the X here is for any given biquad filter. Each of these things that are being generated, both the stuff coming in that hasn't had anything happen to it, and the stuff on the output of the filter, which everything has been done to it, this is all going to be multiplied by something, and you calculate how much. And then that comes back, and you add them. It's plus, 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 plus. You add them together, and that gives you your output. And that goes to the output position. That starts to be echoed into subsequent samples. So this is the last output, and then that's the last output but one. And here is the end result. So that's basically what happens as far as a biquad filter is concerned. And as you can see, it's like a combination of new stuff coming in and the result of your... I've wondered whether you could do a triquad filter, whether you could do it even more complicated or something. But it is nothing but adding 4 different things to your input sample coming in and how loud those different things are meant to be. And that gives you all of the variations of a biquad filter, from high pass to low pass to notches to band pass. You can even make it do shelves. You can have it cut off only a certain amount. And whether you'd have it be doing a broader stroke filter, or whether you'd have it be doing an incredibly tight little band pass at any frequency you care to name. You could have it be an incredibly resonant tight band pass at 20 hertz, or you could have it be an incredibly tight resonant band pass at 16K. It's all in the frequencies, the multiplication factors of these little numbers. You get those numbers right and just add all of those sources together and you've got your result. It's very neat. And it is also not a lot of calculation, way less than something like doing an FFT or fast Fourier transform. And I think that will be it for today. Yeah, triquad. That's why I want to do it, is because it would be a funny name. So on that note, I will bid you folks adieu for today and zip around doing my stuff. I'll talk to you guys later. And thank you for hanging out with me and doing these ultrasonic plugins, which were simple enough that I could talk while doing them a little more effectively. Bye-bye.